Hello, thanks for clicking again. Welcome back to another Innocuous production. Today we are going to talk about PVA and AVP AP FRQs. That's a lot of letters in a row that don't mean much to most people, but it does mean something to you. So before we get started on some of the FRQs, I do need to talk to you about three more little formulas, concepts that you need to be able to work with here before you take the AP exam that involve PVA. The first two have to do with speed. The speed is given as the absolute value of the velocity. So if you're given the velocity equation, you find the absolute value of it, you'll get the speed, okay? In your calculator, the absolute value key can be found easily by pushing the second key and the 0 key, because it brings you to the catalog. And the catalog, the first entry is ABS with a parenthesis. That is the absolute value of something. Okay, so hit second 0, takes you to the catalog. Entry number 1 is the absolute value entry if you need to type it into a calculator, which you very well may, all right, on these problems. Okay, so the next thing we need to discuss is whether or not speed is increasing or speed is decreasing. Okay, speed is increasing or decreasing. So to figure this out, think about throwing a ball up in the air. If you take a ball and throw it in the air, okay, its velocity is positive, right, as the ball goes up. V is positive, but A, the acceleration, is negative, right? Okay, acceleration due to gravity is negative, it acts down. So what happens to the ball when you throw it straight up in the air? It slows down, right? Okay, as opposed to when the ball is on its way down, the velocity is negative. Well, so is the acceleration, and now the ball speeds up, right? So we can say speed is increasing if V and A have the same sign. Speed is decreasing if V and A have opposite signs. Okay, speed is increasing when the ball's coming down because V and A are both negative. Speed is decreasing when the ball's going up because V is positive and A is negative. So that's something you'll see questions on that are going to come up. All right, and the final equation that you need is to calculate total distance. To calculate the total distance of something, you integrate from A to B the absolute value of V dt. Okay? Integrate from A to B the absolute value of V dt to calculate the total distance. All right? The other thing that you can do here is you can find the displacement, right? So let's talk about the displacement, and then we'll talk about the difference between total distance and displacement for those of you who don't know. Okay? So the displacement is just the integral from A to B of V of t dt. So when I integrate from A to B, V of t dt, it would give me, well, the integral of V gives me position, right? It gives me x of B minus x of A. Okay? So displacement, just so we're all on the same page, is if I go on the track at school and I run around the track one time, okay, and then I stop where I started, my displacement is 0. Okay? My ending position and my starting position are the same. So when I subtract them, I get nothing. All right, I haven't moved. It seems like I haven't moved. But my total distance, if I run one time around that track, is 1/4 of a mile because I went around all the way around the track. So my total distance is 1/4, but my displacement is 0 because I started and ended in the same spot. All right. So that's the difference between displacement and total distance. Okay. Those two concepts we'll also need when we talk about these PVA FRQs. All right, so let's look at a couple here real quick. Look at the first one there, which is not numbered. It gives you, it says the particle moves along the x-axis, the particle's position is not given, the velocity is given, and the acceleration is given, and it says x of 0 equals 2. That's its initial position. Letter A wants to know, here it is, if the speed is increasing or decreasing at time t equals 5.5. To figure that out, you would find v of 5.5. Type it in the calculator. Find A of 5.5. Type it in the calculator. So V of 5.5 is negative 0.45337. A of 5.5 is negative 1.35851. Okay, so V and A have the same signs. Same signs. So the speed is increasing at t equals 5.5. All right, since they are both negative, the speed's increasing. Okay, all they have to do is have the same signs. All right, there's your answer to letter A. Let's look at letter B. In letter B, it wants you to find the average velocity for the particle over the time interval 0, 6. To calculate the average velocity, okay, think about your units. That means your units, when you're all done, have to be in meters per second, right? Feet per second, whatever it is. So you're going to have to integrate, okay, v of t dt. So when I integrate v, I get position from 0 to 6. Okay, the integral of v will give me the position. That's measured in meters. But then I want the average, so I got to take 1/6 of that, right? Divide this integral into 6 equal pieces. Okay, so now if you think about what you get, you'll get the integral from 0 to 6 of v is x, right? AVP. So x is measured in meters. The denominator here is measured in seconds. You get an answer that's in meters over seconds, meters per second. So you sure as heck have the average velocity. Okay, if you type this in the calculator, you just get 1.949. All right. Letter C asks now for the total distance traveled by the particle. To calculate the total distance, that's the formula I just taught you. You integrate from 0 to 6 the absolute value of v dt. Okay? Remember, the absolute value key you can find by pushing the second button, the 0, brings you to the catalog, and then hit ABS, which is the first option in the catalog. If you can't find it, if you go on that graphing calculator video that I made a couple days ago for the accumulation function, the very last thing is me showing you how to actually calculate the total distance or find that absolute value key on the calculator. So you can find it there if you're unable to find it. But if you do it properly, you get 12.573. Okay, it goes right in the calculator. So that takes care of B and C. Let's take a look at question D real quick. Question D says on 0, 6 closed, the particle changes direction exactly once. Find the position of the particle at that time. So changing direction means increasing, decreasing, decreasing, then increasing, right? Okay. Or in this case, X is moving along the x-axis. So it means moving right, then switching and moving left, or moving left, then switching and moving right. But either way, what I want to know is where is X? I want to know if X is a min or a max, right? That's really what I'm looking for, because that's where it changes direction. Is that a min or a max? To figure out where x is a min or max, you got to find the derivative of x and set it equal to 0 to find the critical numbers. But if I derive position, I get velocity. Where's the velocity equal to 0? So I can literally type v of t equal to 0 in the calculator. Well, type v of t in the calculator in the grapher and see where it equals 0. It equals 0 at 5.19552. Okay, there's my one value, but I want to know the position at that value. Okay, so I want to know its position there. So to figure out its position, well, all I have is v. So to find its position, I got to integrate to go backward one step. I'm going to have to integrate from 0 to 5.19552 v of t dt. Now, where did I get the 0 from? The only other thing that I'm told in this problem is that the initial position is 2. So x of 0 is equal to 2. So that means if I start from 0, I can stop at 5.19552, which is this time, integrate v of t, but then I have to add on the 2. This is an accumulation function, right? Okay, you're given the rate, you got to integrate to get the total plus the 2 that you started with. Okay, you started from the initial position 2. All right, and if you do that, you'll come out with 14.134. Okay, again, you got to use this whole decimal here in the integrand or into the integral until you reach the final answer. The final answer comes out to be 14.134. Then you can round it to 3 places after the decimal. All right. Okay. So let's go on to the second one here on the bottom. All right. Which is number 1. Karen rides a bicycle, and you're given a graph there. Okay. Letter A says to find the acceleration of Karen's bicycle at t equals 7.5 minutes. You're given that graph as the graph of velocity. So to get the acceleration at 7.5, well, you would have to calculate to get a of 7.5, right? That's going to be v of 8, is that? Yep, v of 8 minus v of 7 over 8 minus 7. You got to find the slope, right? You're given the velocity. To find the derivative of velocity, you get the acceleration. So to find the derivative of velocity in this case, you got to go find the slope. So find the slope of that line. The slope of that line is negative 0.1. The numerator is measured in miles per minute. The denominator is measured in minutes. So if I take miles per minute, I get miles per minute squared. It asks me for the units, I have to give them. Okay, it asks me for the units, I need to give them. So my answer is in miles per minute squared. All right, let's try letter B. For letter B, it says using correct units, explain the meaning of the integral from 0 to 12 absolute value of v of t dt. So the integral of the absolute value, this is the total distance Karen biked from t equals 0 to t equals 12 minutes. Okay, absolute value of v, integral of absolute value of v is the total distance. All right, that takes care of the first part. The second part is to actually calculate the integral from 0 to 12 of the absolute value of v dt. All right, so absolute value of v. So now if you come and you look at the graph here, let me bring it into the screen here. There's your graph. Okay. Well, to integrate v, well, integrate absolute value v, or just integrate v means find the area, right? I have to find the area that's underneath the curve. So I'd have to find this area, this whole area here. Okay. This area is underneath. It's supposed to be negative, but remember, it's absolute value. So that means that this triangle will flip up over the x-axis now, right? Because there's no negative values for y anymore. So it now looks like this, that triangle. I need to find this area as well. So the total distance can be found by finding this area, and all this area that's here. Okay? And if you do that okay, you apparently get 0.2, another 0.2, and a 1.4, which is 1.8 miles. All right? That takes care of letter B. So let's go on to letter C. Letter C, it says, shortly after leaving home, Karen realizes she left her calculus book at home. Well, that's important. And she returns to get it. At what time does she turn around to go back to home? Okay. So the question is, when does she turn around? Well, remember, V is positive, so that means X is increasing, right? When V is positive, X is increasing. X is increasing until we reach 2, because at 2, V changes from positive to negative, which means that X changes from increasing to decreasing. Okay? So V is positive, so then X is increasing, right? The one before it. When V is negative, X is decreasing. So since it shows, the question says Karen is moving away from her house, so starting from here, she leaves her house, right? So when X is when V is positive, the distance between her house is getting bigger, right, for where she's located. But then at X equals 2, it changes and it goes to negative. So that must mean she's going back to her house, okay? Because the distance is there, or the position is now decreasing. So it happens that T equals 2 because V changes from positive to negative. There's your answer. That's it. All right. And then finally, for letter D, it says Larry also rides his bike along the straight road from home to school in 12 minutes. His velocity is modeled by, so W of T is the velocity for Larry. Who lives closer to school, Larry or Karen? So it takes him 12 minutes to get there. So I guess to figure out how far Larry lives from his house to school, you could integrate from 0 to 12, W of T dt, right? You give him the rate, you integrate, you get the total amount of distance that he has to go. If you do that properly, you come up with 1.4, okay? Now, Karen, for Karen, if you look at the picture, this is 0.2, this is 0.2. All this must be 1.4 if you calculate all of its area. So how far does Karen live from home to the school? How far is the school from her? Well, she goes 0.2 units, right? Okay. So, all right, let's do this first before we do that. To figure out how far Karen lives from school, you'd have to integrate from 0 to 12 V of T dt. All right, given the rate, you integrate, you get the total. So now to integrate V of T, I got to find the area. Okay, so I got to find this area under the curve. So this is 0.2. So I have 0.2, a negative 0.2, it's underneath, and a 1.4. 0.2 minus 0.2 plus 1.4 is 1.6. So who lives closer to school? Larry. He lives 1.4 meters, or whatever this is, miles, 1.4 miles. Karen lives 1.6. Okay. And this 0.2 negative 0.2 should make sense to you because the 0.2, right, the 0.2 miles is Karen going from home on her way to school. And then remember, at T equals 2, she turned around and she went back. So she went a negative 0.2 because she had to get back home again. Okay, she had to get back home again. So she lives a total of 0.2 plus 1.4. She lives 1.6 miles from the school. All right. All right, so that's a review of PVA and a couple of extra things that you probably maybe didn't know. So with that, you can try some of those problems. And if you have questions, you can ask tomorrow. All right, have a great day.